So let's start, everyone. Good afternoon, everyone. Welcome to the summer seminar series jointly sponsored by the Climate Change Information Center and the US Embassy in Cairo. Today, we'll be hearing more about the global water cycle. Our guest speaker is Dr. Engineer Peter van Oevelen. He's joining us from Boulder, Colorado, where it's 5:30 a.m. in the morning. So I have to thank him for starting his day so early. And Peter is the director of the International GWEX Project Office, located at the Center for Ocean Land Atmosphere Studies at George Mason University, Fairfax. That's actually the same institute that I graduated from when I did my graduate degree with Dr. Shukla. So it's like my alma mater. Peter is also professor of practice in climate dynamics at George Mason. He received his PhD from Wageningen University. I hope I said that, pronounced that right. And his background is in agricultural hydrology and the use of satellite observations, in particular also radar observations, to better understand land surface changes at regional and global scales. His main area of interest is international research collaboration on climate, energy, and water. I also discovered recently, actually about an hour back, that he is the owner and instructor of Shenandoah Paragliding LLC that provides instructional tandem paragliding flights as well as instruction to become solar paragliding pilots in the DC area. I didn't know this about you, Peter. I wish I'd known earlier before you moved to Boulder. So GWEX stands for the Global Energy and Water Exchanges, and it's one of the programs of World Climate Research Program. And GWEX has a new science plan. Peter will tell us something about that plan. It's mainly to understand and predict changes in water availability, both at local and global scales. And Peter will also touch upon some issues for the Middle East, Central Asia, North Africa, this region. I think in the new plan, they want to focus a little more on the areas that they haven't paid attention to in the past. So the title of Peter's talk is The Changing Global Water Cycle and the Middle East and North Africa. I will now turn it over to Dr. Ahmed El-Kenawi. He will say a few introductory remarks, and then Mr. Chakfi will also give us some remarks. Actually, it is Chuck's last week here with us in Cairo, and so we want to thank him for all the support he gave us in developing this seminar series. Peter will then give his talk, and then the Q&A will be moderated by Dr. Ala Nasser. So without further ado, I will turn it to Dr. Kenawi.
Good afternoon, everyone. This is Ahmed El-Kenawi. I'm a researcher in the Climate Change Information Center. I'm assistant of Dr. Fahim. Today, I'm delegated on behalf of the team and Dr. Ala to give you a remarks about the topic of today. Continuing the series of sessions and the presentations that we started in July about the climate change impacts and events in the agriculture sector and its negative impact in the resources. So today we have an interesting topic about the water and watery challenges in North Africa and in the MENA region. And just let me give you a few remarks about the water sector in Egypt. Maybe it can serve Dr. Peter, give him a better idea, better understand about the water sector in Egypt. That Egypt faces many challenges in the field of water due to limited water resources and negative impact of the climate change. Total water resource in Egypt is about 80.25 million cubic meter per year. We receive almost 55.550 million cubic meter square from the Nile River. We have a deep groundwater 2.1 million cubic meter. For the rainfall, when 1.30 billion cubic meter. Desalination of the seawater 0.35 billion cubic meter. And the shallow groundwater about 7.5 billion cubic meter, and they use the agriculture drainage water 13 0.5 cubic meter. Nowadays, we face challenges regarding to the climate change, such as increase in the temperature and the resulting increase in water need and water requirements of the agriculture crops. These challenges make the Egyptian state to put the water challenges and the water issues in the top of the agriculture action now in the World Water Week in Stockholm, and even in all the water in the climate action in the COP27, which aim to speed up the adaptation and the mitigation climate measure, setting future plan to reduce the emission and providing necessary funding for climate change adaptation and the mitigation project for the Ministry of Agriculture and Ministry of Water, Irrigation and Water Resource. And now Dr. Czech may give us like his speech as he remarks, or Dr. Peter, whether who is ready.
Great. Thank you, Dr. Ahmed. Thank you, Dr. Peter. Thank you, Dr. Angeli. This is Chuck Fee from the U.S. Embassy. As Dr. Angeli mentioned, my 3 wonderful years in Cairo are coming to an end. I'll be leaving tomorrow, late in the night, but then I'll come back for the COP27. And I'm very excited to learn about the stuff Dr. Peter's talking about the water cycle. Obviously, it's very, very important to Egypt, an existential threat. The change in the water. So lots of interesting science being done there, and also very timely. There was actually an article in yesterday's New York Times about how they discovered an old branch of the Nile that helped them build the pyramids. So it was a very interesting article that I read just this morning, talking about how climate change in the year, 600 BC, may have changed the way the Nile flowed and changed why they stopped building pyramids there. So very interesting stuff, and totally in line with all the water challenges that we're seeing over geologic scales. I also want to mention, very interested in when Dr. Peter can tell us about using the satellite imagery. Very, very interested. I know we had a talk a couple weeks ago about using satellite imagery to protect cultural sites. So it's very interesting to hear how we can use the satellite imagery to also understand the water resources. So very excited to learn more, and thanks to everybody for calling in today.
Over to you, Dr. Peter.
Okay, great. Thank you very much. Let me start sharing my screen. And I have to do whole screen. Okay.
It is working. We can see your screen.
Okay, great. I've got a little less than half an hour, so I try to, I'm not sure what my screen. You can still see my whole entire screen. Let me see, wait a minute. There we go. I'll try to go through it. There is a lot more I could talk about, but I have to keep it sort of on the surface, literally. I'm going to talk about the changing global water cycle in Northern Africa and the Middle East. My background is in actually, I'm working for the Global Energy Water Exchanges Project Office, which is part of the World Climate Research Program. So that's important to know. I'm going to quickly go through the background message, sort of what do I want to sort of present. A little bit about me, but I keep that very brief. Talking about the assumptions I've been making while giving this talk. I give a general description about the global water cycle, how it is changing and why that matters. And then I'll conclude with a new project that we're trying to start up in the Mediterranean basin. And I also will touch upon 2 other endeavors we like to start, one in Central Asia and one in Africa, Sub-Saharan Africa. So what is it that I want to convey is that we can only manage our water resources if we understand what is happening to these resources. So we need for that continued research and certainly more observations to make informed decisions about how to use and share these resources. Water is everywhere undervalued, overused, misrepresented, and policies related to water are often outdated. or based on incorrect assumptions. And when I say undervalued, it's both in terms of price, really costing, economic value, as in sort of realizing how scarce that resource can be. We have many solutions already available from a technological point of view to actually address water issues, but often, for instance, policies are not adequate or are standing actually in the way to use these type of technologies. We have to address water-related challenges at the lowest cost, and we should try that by addressing these policies at every level, local, state, federal, multinational, and change them. That, of course, doesn't mean that we can just leave it at that. I think individually, we all need to become more water conscious. It won't run out globally, but that doesn't mean that you won't. And talking as part of a climate science collaborative organization, the World Climate Research Program, and in particular, the Global Energy and Water Exchanges Project, we need the local and regional perspective. We need, in particular here, your perspective from the Middle East, from the Northern Africa, and your knowledge about how do you see things, how do you experience things, what do you observe, and can you share that knowledge and information and data with us? A little bit about me, I keep it very briefly. I come from the Netherlands, and hence that means, of course, the standard things like cheese and soccer and all those things, wooden clogs. It's a country of 17.5 million inhabitants. It's very densely populated. It's small. It's the 131st in size. Nonetheless, it's the second largest food exporter in the world after the United States. And with that, I want to just emphasize is that we can be much more intensive about our food and food production, but of course that comes at a cost. But I won't go into detail about that. But it's something that I want everybody to realize is that there are still a lot of ways we can intensify our agriculture and actually minimize our water use. Also, coming from the Netherlands, it means that I've grown up with the realization that water, in particular, flooding is a serious issue. And since this year, I think drought is a new realization, in particular in Europe, but certainly in the Netherlands, is that we're not just being prone to flooding, but drought is becoming a serious issue as well. But from that perspective, I give my talk. That is how I've been raised. Some assumptions. I assume climate change is real, of course. In particular, global surface temperatures are increasing. I will try to give this talk primarily from observational base. So I'll leave out modeling. I will touch upon it. I will also look at it primarily focused on water. I will give a generalized description. I have to leave out many details and certainly certain phenomena like hurricanes. I will focus on water quantity, not so much quality. And I certainly will not discuss water as a right versus a commodity, although that's a very interesting and necessary discussion to have. So basically, it's a very condensed introduction to global hydrology. And I do that from a land atmosphere processes perspective to make sure I'm not an oceanographer. So GEWEX, what does GEWEX do? We facilitate, enable, coordinate international climate and related research activities with an emphasis on land atmosphere processes and interaction. And we do this from subsurface processes related to hydrology to atmospheric processes. And we include interactions between the higher atmosphere, so between the troposphere and the stratosphere. Our focus is water as a local challenge, but it's driven by global processes. We focus on improved understanding of the relevant geophysical processes of water and energy. And the last 5 to 10 years, we've been more and more looking at what the human dimension of that is. And I'll get to that in this talk. And water and energy security are intrinsically related to food security. And if a lot of talk is always about the water energy food nexus, to me, it's more the water energy people nexus. So that's sort of what we do. GEWEX is process oriented, so it's much less on applications, but we provide data and background information for many applications. Quick overview. We're structured through 4 panels looking at different aspects. The GEWEX data analysis panel, which looks at global data sets and assessments, the global atmospheric system studies, the global land atmosphere system studies, and the GeoX hydroclimatology panel. I just give this as a quick background information. If you want to know more, please feel free to contact me. And these slides should be available or can be made available, no problem. So the topic, the water cycle, the very basics. The water cycle in I think its most elementary form can be represented by precipitation minus evaporation equals the change in storage plus runoff. Basically, we're telling that, we have the oceans primarily where water evaporates. It basically becomes water vapor. It can condensate into clouds. It can then become precipitation, fall over land. And there it can, run off, it can be stored, but it also can be evaporating again and run off to the ocean, and then it starts all over again. In this simple description, we neglect human intervention, water management in particular, and quite a few other things. But this is sort of a very basic, useful description at a global basis. Also, globally, water is conserved. It will not get lost. It can change its face. It can be absorbed by soil, plants, etc., but it will not disappear. And I think that is something that people need to realize. We will not run out of water globally, and that's an important thing to remember. A different way to look at it, and this is is how do we observe the water cycle? And we can do that, of course, from in situ observations, using rain gauges, etc. And but we can also use satellite observations. And for precipitation, we're thinking about TRIM, unfortunately not running needed, but GPM these days, the Global Precipitation Mission. M3 are an example of instruments that from space can observe precipitation. We can also look at the change in storage, and in particular, the GRACE satellite, which looks at sort of changes in gravity, can tell you something about how much water is there. But it's a very relatively low resolution. And we're talking with low resolution, I mean, hundreds of kilometers versus precipitation is more in the order of 10 kilometers. Runoff or less. Runoff in situ primarily these days, or with radar altimetry. And a new satellite, which is going to be launched this year, is the Saltwater Ocean Topography Mission, which hopefully will give us much more information about the river and lake levels, and that can tell us something about runoff. And then evapotranspiration, that's probably the most complex one to observe directly or more directly from space, and we need quite a modeled effort for that. We use land surface temperature primarily to estimate evaporation using instruments like M3 or some of the Sentinels. What is important in all of this, when you bring these satellite observations and in situ observations together, either just looking at satellite observations or just looking at in situ or combination of both, it's important to understand what the errors are in these data sets, what they actually represent, how accurate are they, how consistent are they over time, and stability. It says ability, but it's stability. So really bringing these data sets together is not as straightforward as it might seem, because these things change over time, and we have large uncertainties in some of these observations, and that complicates it quite a bit. So it is a challenge for hydrology to create climate data records, in particular for the terrestrial water budget, using in situ and remote sensing observations. And as I pointed out, we can do the change in storage from GRACE. We could do evaporation from some of the surface temperature measurements from space. We can do precipitation from CMOR for GPM, and runoff from altimeters. And then we can sort of come up with an estimation of the budget. So when we do that, before we do that, there has been for a while some estimates of how much water is available. But we have to be careful at how we approach it. As I pointed out, water does not get lost. It is actually a water cycle. It cycles through our Earth system. So when we take a snapshot in time, then 95 or 96% of that water is in the oceans. And about 2.5% is fresh water. From that 2.5%, most of that fresh water is in the ice caps. Quite a significant amount is still in groundwater, although we have difficulty to sort of really observe or measure how much that actually is. And then the smallest part is actually in the fresh water in our rivers, lakes, etc. And then from that we have, ground ice and permafrost is another big one there. But that's a static image. Actually, when we look at how much cycles through, then we see a different issue. And I go back. And I will show later on, but actually most of the water moves through the atmosphere and then of course back through the land, through the rivers into the ocean. And when you're looking at how much water moves through the ground, it's a lot less. This is something that we really need to realize is that, yes, the static picture doesn't tell you actually where the most water is because it's constantly cycling through. Groundwater is not cycling through as quickly. And hence, there is, when you look over time, there is more water in the atmosphere and in the rivers and lakes than there actually is in groundwater or what's moving through permafrost and ice. So what is a global water cycle? As I tried to point out, it's not a changing amount of water as it is preserved. It is actually a changing distribution of water in space and time. It can be more water in the atmosphere with higher atmospheric temperatures. It also means a change in water availability. Some regions will get more, some will get less. Changing intensity and duration of extreme events. Sometimes precipitation will start increasing, but it will become in more extreme events and less on average. Changing phase, more water will probably come as precipitation and not as snow and ice. Changing quality of water. And changing global storages. The ice sheets is a nice example. And change in fluxes. So the changes, as I point out, for instance, with extremes, is in precipitation, runoff, and flooding, etc. So water is a local challenge, but it's driven by global processes. So can we state that our global water cycle is changing? And we have quite from satellite observations on the left, done some estimations, and I give another one on the right, where they sort of try to estimate the global water budget. And from that, we sort of can say that, yes, things are changing, but in particular in the way things are distributed over the globe. Averages have not changed that significantly yet. And it's been hard to, given the uncertainties, to really pinpoint, for instance, the global changes in precipitation. We have some anecdotal evidence that we see increases, both in river runoff as in precipitation, but on a global scale, it's different. Regional, we can state that a little bit clearer. Again, I showed this picture before. So this is sort of the 2D schematic of the interaction between water and the radiation from the sun that drives the water cycle. And when you look at it from sort of more a bird's eye view from above, then you sort of can sort of picture how it looks from above. And when we then go through sort of a cut through, you can see that, large scale circulation is important, how water moves through the atmosphere, how that advective processes like large scale precipitating systems, or more in convective systems, where like thunderstorms, etc., mesoscale convective systems, and runs off. So this is just a nice figure to sort of show quickly how these things can interact. So yes, the global water cycle is changing, although from an observational point of view, it's been difficult to really pinpoint it given some of the uncertainties. But we can show that, in particular, like precipitation, it is increasing. So why should we care? And in particular, what does that mean for Northern Africa and the Middle East? So in particular, as I point out, water and food are strongly linked, and water cycle is the main driver of food production. Without water, no food. A warmer climate pushes the water cycle into an unknown territory. the terrestrial water cycle, but actually the global water cycle in overall, is not entirely natural anymore. The human influences are significant. I mean, first of all, the cause of global warming, of course, affects the water cycle directly at a global scale. But when we purely look at the terrestrial, over land, what water is doing, then humans are really strongly influencing what's happening with the water through their dams, through irrigation, through land use change, etc. So there is an urgency to understand that new state of the water cycle. For a long time, basically up to probably 10, 15 years ago, we really looked at it as a purely geophysical process, maybe biogeophysical, looking at plants, etc. But humans were not really at the heart of our thinking, and that has changed drastically. We realized that humans are really influencing the water cycle. So what is the current situation? And don't go in details and numbers, but food production increase is slowing down. So we are still producing more food globally every year, but that increase is slowing down. With the expected increase in global population, that will, of course, provide an issue. The change in production, however, will differ per region, and with climate change, that will also change. So factors determining food security are quite a few. Population growth, of course, is very important. From the World Climate Research Programs and GWEC's point of view, water scarcity and climate variability and climate change are the things that we primarily are looking at, how that influences water availability and food production. So when we look at agriculture and fresh water, agriculture uses globally about 70%, and I think in Africa it's about 85% of agriculture, 10% for household and 5% for industry. Again, that's withdrawals. Of course, all that water at some point comes back and returns into the ocean. So you have to keep that in mind. And then on the right side, I give, and I hope you can see my pointer here, I give some other things by agriculture. They contribute about a quarter to the greenhouse gas emissions. About 37% of Earth's landmass is used for agriculture, and water withdrawals, as I point out globally, is about 70%. So these are big numbers, and hence when you see how water is changing, that affects these numbers. It affects where we will be able to have agriculture. It affects, of course, the water withdrawal directly, but it will also affect greenhouse emissions. And if we have to transport, for example, food over larger distances. So the future of our water is really determining the food for our future. The world population growth is about 2.5 billion people from 2015 until 2050, and that's a considerable amount. And that means that food production has to increase with about 40 to 60% in able to actually feed these people. On the positive side, slightly, is that we have 30% of food waste, so we can actually gain a lot there. But nonetheless, even if we address that significantly, we still need to withdraw a lot more water. It is a renewable resource, as I pointed out, but still that increase will be really, really difficult to make. So we will need to make changes in how we produce our food and how we use water in that process. State of the water cycle, to sort of emphasize how water cycle is changing, and this is a nice figure showing the temperature over the different regions. And I think I'd like to point out that, you know, everywhere we see that increase, which is expected, but what we did not, or what I did not expect, is actually the differences in precipitation and how that is changing. And the Middle East and Northern Africa and Pakistan and Afghanistan is actually almost opposite of all the other regions. So this is something to really look at. And I'm not sure what the longer term picture of this will be, how that will extend. But we can see that there is quite a significant increase in variability. And that is in itself already a difficult thing to deal with. But I found it very interesting, this opposite reaction. Of course, Sub-Saharan Africa is here, and we see, of course, a slight increase there in the last couple of years. Quickly, an overview of the patterns of climate hazards. And one thing that I noticed is that, for instance, in Egypt, which is not expected, or which is very well explainable, droughts are not a big issue in itself when you look at the state of the climate in Egypt, for example, because it's a very dry country itself. But what I noticed that Pakistan, for example, but also other northern African countries, flooding is one of the bigger hazards. So we see that with an increase in precipitation and a more variable precipitation, it will only get more extreme, and that is not a good thing. I'll skip this one. This just emphasizes the different disasters, pinpointing in particular the importance of flooding in the region. So I'll do a simple analysis about regional changes in the water cycle of the Nile River Basin based upon some of the publications. The Nile River Basin covers both regions where the precipitation is expected to increase, in particular in sub-Saharan Eastern Africa, and others where it's expected to decrease. However, this increase is not likely to be uniform, meaning that, yes, there will be more precipitation per year, but that precipitation most likely will fall or will come down in shorter bursts. Temperatures continue to increase, and that means, for example, over the entire region, that evaporation will increase as well. So all in all, just from a purely geophysical point of view, there might be less water available. But what drives this really is that the supply side is changing, but also the demand side is really changing. The human use in the region will change drastically, and sub-Saharan Africa, for example, will be the region where the biggest population increase is expected. Hence, the pressures on water resources in that region will increase too, and that will also have its consequences. And I don't have to tell you that. So really, we can expect more erratic flows in the Nile River Basin and less water available overall. And the human interaction, how we deal with this, will actually determine largely what the outcome is. So what is so difficult in actually really projecting how these changes will be is that the monsoon regions over Africa and the middle and eastern Indian Ocean and in the ocean, sorry, is changing, and we sort of see that it is changing, but we don't exactly know what the longer term effect will be. And but small shifts in the monsoon can have, of course, drastic effects for the various river basins in this region. And to pinpoint this is one of the few model examples I'll give is model precipitation change over sub-Saharan Africa. And what all of them show is that there's an increase in sub-Saharan Africa, but then you go to South Africa really further down and there will be significant drying. What also noticed here is that there is an increase in precipitation in the Horn of Africa. So far, of course, if you look over the last couple of years, we've seen that actually has been drying. So yeah, this is a model result. This is what we expect by the end of 2100. Of course, we have to be careful with looking at these figures because they don't take into account human adaptation. It's relatively coarse resolution, so it doesn't account for topography that well. And also these are mean figures, primarily these models, the GCMs from these global climate models, look at more the means and not so much the tails of the distribution, not at the extremes. So we have to be very cautious how we interpret these results. And as I point out, these monsoons here sort of depicted by the green parts where the wet parts of the monsoon and then the yellow parts which are the dry parts. We can see that the North African and South African monsoon or the East and West African monsoon, yeah, slight changes in particular for the Nile River Basin can have huge impacts, and hence a lot more research is actually needed to figure out how that is changing. And this is not just for Africa, this is actually globally. We really want to know how the large-scale global circulation, how that is changing, because it will affect the water resources of many regions in the world. Central Asia is another area where we see significant changes. South America and also North America, the monsoon this year here in the US has also seen some significant changes with a very wet year, actually. So to conclude, because I'm getting to the end of my talk, I will talk a little bit about one of the ways that we look at all these phenomena, and we do that through what we call regional hydroclimate projects, and I will focus also on one of them that we are starting is Future Mediterranean. So what are regional hydroclimate projects? They're generally large, regional focused, multidisciplinary projects that aim to improve the understanding and prediction of a region's weather, climate, and hydrology. All these regional hydroclimate projects address the geophysical processes surrounding water and energy, and hence they address sort of the main goals of GeoX. However, most of these regional hydroclimate projects are much broader than this, and in particular look at questions that, of course, are directly relevant to society. I mean, that is what we ultimately do it for. So they look at the biosphere, the carbon cycle, the human interaction in the landscape. And a nice example, for example, would be sort of like eutrophication of the Baltic Sea is a nice example. But these projects for us are a good way to look at what's happening in a region through the expert knowledge and observations from local scientists. So why is GeoX interested in this? Well, we're a research collaborative organization. We try to bring research together, and basically in Middle East, Northern Africa, Central Asia, we are not that well represented. So we like to have more interaction and more input. It's also regions where water issues are critical and very vulnerable to climate change. High mountains is another aspect that for GeoX is important, as well as for the World Meteorological Organization. So we're looking at that as well. And we like to link these communities to the various other regional hydroclimate projects we have around the globe. And we use these also to test, our global data sets. How good are these? What are the uncertainties? Where are the errors? And as pointed out, and I keep pointing it out, is that we need that local regional perspective. How do we go about it? We try to improve our scientific foundation and capacity. So we try to increase our observations. We try to increase the computational capability, etc. We try to organize winter schools, workshops, conferences, etc., just to build a regional scientific network. And we try to do that together with the folks in the region. Of course, what is it in them for them? It's basically international network of climate and weather and hydrological scientists, top-tier network, state-of-the-art modeling access, capacity development where we support it, etc. And I want to stress that it is supposed to be regional-led and run. It's not that we have people come in and do the work. That's not the idea. A quick overview of how we started in the 90s with these experiments. It started out all with GSIP in the US over the Mississippi River Basin. We had then also one over the Baltic Sea region, Baltex, the Mackenzie River Basin, the Amazon River Basin, and one over the Lena River, as well as Tibetan Plateau in Southeast Asia called GAME. And in blue are the later ones, and I'll quickly skip through it. And these are the current ones from 2010 to 2021. But to point out, Future Mediterranean fits in sort of where we are these days. The purple ones are the sort of regions of interest where we want to do new things. Asia PAX is starting off, Third Pole Environment is starting off. Future Med is becoming a reality. They're trying to sort of do a follow-up on HIMAX. And we also try to use an US RHP. The hatched ones, the Global Water Futures, Andex, Panex, and Baltic Earth are the current regional hydroclimate projects that are active. So Future Med, The Mediterranean, because it's a climate change hotspot, warming significantly faster than the rest of the world. It's a complex landscape, and lots of things come together here. And of course, the region droughts and desertification is a phenomenon. We really want to understand better what's happening. The other thing is that the Mediterranean basin is relatively closed, so it's an interesting region from a purely geophysical point of view to look at. The Future Med will be designed as a transdisciplinary and cooperative international program, and it will be done through different ways. One of them is setting up a supersize network, and the other aspect is a big online platform to have people work together in several ways. I want to point this out. These are the current super sites that's set up. If we could add a few more, that would be fantastic. I would love to see one in the Nile River Basin, in particular, the Delta. But there are some opportunities to do this. And these projects, take usually 10, 15 years. So there is some time to join in if possible. And I really, because I see I'm running over time again, want to thank you for this. I apologize that I cannot go really in depth in many of these things, but I hope that I sort of touched upon some of the things that are of interest for you. And I look forward to your questions, and thank you for your attention.
Thank you so much, Dr. Peter, for this. This was amazing for me. I'm not an expert in hydrology by any means, but I'm trying to learn as much as I can. I'm waiting to get questions from our audience today, but until they have any questions, I have 3 questions for you. The first one is about the different types of water. I keep hearing different terms. We have a blue water, green water, we have gray water, and we keep hearing more and more terms about water. If you can just elaborate more about that. And my second question will be, based on your experience in water, how can we here in Egypt work in reducing our water footprint? How can we take the appropriate step to do so? And my third question will be about the future Mediterranean. How can we be part of that? So take your time. I know a lot of.
Okay, no problem. Thanks for the great questions. So I'll start with the last one. Future Mediterranean. So I gave here the contact person, Samira or Samiro Kodayar is the one that you can contact directly, but you can also contact me in my office. There are different ways. You can basically just say, hey, I'm interested in taking part, and tell what your interest is and what you do. So if you're doing hydrological modeling in the region, then yeah, by all means, if you're having access to observations, great. There are many ways that you can take part in this, and Samira can certainly tell you how to do that. So it depends a bit on what your background is and what you're interested in, how you can take part. But these are voluntary efforts, and some of these projects are centrally funded, and there's a big pot of money available. But actually, many of them are run through institutional funding and much more through collaboration, saying, oh, we have a PhD student here or a postdoc who can actually, his research or her research is already in that area and they like to contribute. So there are different ways to do that. So the second question was how you can change your water footprint. Well, there are many ways to do that. I think recycling is, one of the most important things that we can do. As I pointed out, is that redistribution of water is the main problem. But if you're in, say, Egypt, and yeah, you have several resources. The Nile is the big one, but groundwater is another one. But groundwater is really not that renewable. A lot of times it takes a long time for groundwater to renew itself. So it is basically, that's a resource that you have to be really cautious with. So if you can sort of reduce that and recycle water, and that means often an increase in infrastructure in actually using that water. And that comes to sort of what you're talking about, the blue water, green water. It's like, okay, how is that water flows through the system? And yeah, if you do agriculture production, then of course that water will be exported as in the form of food. but that's a relatively small part. And if we can recycle more of the water we're using as households, as industry, etc., we can really significantly reduce our footprint. As I said, I have a little difficulty with the word footprint sometimes, as with these terms, these definitions of different types of water, because water flows through the system. It's not that it gets lost, it's just redistributed. But a lot of times it does come back to the region. The problem is, as we see, for instance, now in like Pakistan and stuff, with the changing climate, precipitation become much more intense, and we get too much water, and then we don't know what to do with it, and we can't hold on to that water. So how to store and recycle water is going to be really one of the bigger challenges for many regions. Often, and I see that also in the US, it's the realization too late that they're running out of water. The reservoirs are running empty, but these reservoirs are run often at such a way that, in particular in California, to account, make sure that river systems don't flood. So they get rid of sometimes water too early. So water management in this way is not as straightforward as a lot of people think. So there are many complex things that you have to take into account. I can talk forever about this, but I'll leave it at that for now. Did I answer your question?
Yes, thank you so much, Dr. Peter. I have a question from Dr. Anjali here.
Yeah, thank you, Peter, for such a nice overview of all the issues, firstly at a global level and then honing in on the MENA region. It was really wonderful. I wanted to ask you about desalination. I know it's not really the water cycle, the core of water cycle issues, but for example, intrusion, as we see sea level rise in a changing climate, the intrusion of the water from the Mediterranean Sea to and how that might impact agriculture. How much understanding do we have of this, at least elsewhere, that we might be able to borrow from it? And also desalination in the aquifers as well. Is that a big issue? So yeah.
Okay. That's so indeed. And I know that even the Netherlands had that problem with salt water intrusion when you have higher sea levels. Then of course the pressure from the ocean, from the sea onto in particular groundwater increases, and you can have creepage into. That is a problem. And in particular, it's a problem when you start having droughts. So you have, depleting groundwater reservoirs, you have less water coming in. Desalination is in part a solution. I would say that desalination, in my view, and this is a very personal view, is sort of an add-on, helping you through the difficult times. It shouldn't be a structural solution for your water shortages, but it should help you in those short periods where you have actually water shortages. So basically, it's one tool additionally, in particular because you have to get rid of the brine, the salts that you take out. They need to go somewhere, and there are lots of time useful minerals, etc., in there. But it's a costly affair to actually take care of that water. And when you just dump it back into the sea, then you have a lot of environmental impacts. If you store it over land, similarly, you will have environmental impacts. So that is the disadvantage of desalination. It's not a, the panacea, as they say, to our problems, but it's one tool with many to actually address the issues. Saltwater intrusion is something that requires really proper water management, and that means that you have to have sufficient water in order to tackle that. When your groundwater is becoming salt, particularly in delta regions, coastal regions, that's a complex issue, and that's I don't dare to say too much about that. I know that in the Netherlands we had two issues. One of them was salt water from the Meuse, from France, from the mines there, that was coming in from the land side, along with intrusion from ocean. And They managed that by A, cleaning up the river, and B, by trying to figure out how to make sure that there was sufficient water pressure from the inland side to make sure that there wasn't too much intrusion. But again, that requires sufficient water. So I'm not sure how to tackle that for every region. That's not my area of expertise. Hope I answered some of it.
Yes, thank you. Yes, you shared insights at least. Yeah. And also, what are some of the best practices in the Netherlands? You know, I was quite surprised about learning that Netherlands is the second largest food exporter. And so, wow, that's really wow. Hats off. How did they achieve that?
Yeah, that's a good question, and it's actually one of the reasons I raise it is that we have greenhouses, so that's a big part of it. Greenhouses in one way are ideal because you can actually circulate a lot of water in them. Of course, you still need water because, you know, when you grow plants, they'll take up water. But a lot of it can be done much more efficiently. So you won't lose it entirely to the atmosphere by evaporation, but you can actually contain it within your greenhouse. And that really increases production per area. Of course, it comes also at a cost because when doing that, you need a lot more nutrients and minerals. So the intensification means that you have to import or make sure that you get all these requirements there. So the water, can become more polluted, for example. Your nitrogen pressures, big discussion currently in Europe, but certainly in the Netherlands, increases. How do you deal with that? Yes, you can intensify, and you can do that in many ways, but there will be some environmental costs to that. And it's a balancing act. I think certain regions are much better suited than others to do that. But I think like Egypt, but also like Ethiopia, for example, with flowers, which are not food, but it's another example where you can really intensify the production and be much more efficient in how you produce these things. And that, I think, for the Mediterranean is one other thing that again is one of the tools that you can use to improve. But it comes at a cost. It's quite a big infrastructural cost. And the disadvantage is that food export means that you have to transport food over large distance, and hence that comes also at a cost, both in terms of water as well as in terms of energy.
Thank you so much, Dr. Peter. I have a last question, and if nobody else has any question, I will wrap it up at 2:30 exactly. I will defer to Chuck's question about satellite imaging. How can we use that in taking care of our water here in Egypt and managing the situation?
Yeah, I mean, satellite observations are a fantastic tool to really monitor what's going on. And the water cycle in particular is affected by several things. We can observe, as I pointed out, with certain instruments, try to do that directly. But what you also can do is, observe changes in land use, land cover change, where water is going, sort of also figure out what are, the drought-prone areas, what are the flood-prone areas, what can you do there? Satellite observations are a really fantastic tool to investigate many issues, and can give you a relatively quick and good overview at a national level, and for us also at a global level of what's going on. And if you're looking at it from a global level, then yes, satellite observations are critical to our climate models, our climate studies. But when you zoom in, you can, even at high resolution, actually get even more detailed information and do even more detailed modeling of what's happening. And over Africa, for example, I could see that we can probably improve our projections and what happens to our water much better if we used higher resolution models and go to what we call convection permitting models, which are models that run at around kilometer scale. And they can give you a much better indication of what is going to change, because they're much more sensitive to what's happening on the ground and topography.
Thank you so much, Dr. Peter. I don't know if anyone else has any questions. He or she can just raise their hands.
Or unmute themselves.
Or unmute yourself and just go ahead and ask. I don't think we have any more questions. Then I will just thank you so much, Dr. Peter, for your session today. This was very assuring for me to know that we are not losing water, it's just redistributed. So that was very comfortable to me. Thank you so much for your time, and very sorry to wake you up this early. I wish you a great rest of the day. And Dr. Angela here, do you want to say something?
No, just thanks again. I want to express my thanks, Peter. If there are any questions from the attendees, they can get in touch with you later, and especially if there is interest in participating in some of the joint activities for the region.
Yes, absolutely. Yeah, feel free to directly email me, and look forward. It was a pleasure, and thank you again for the invitation.
Thank you so much. Have a nice day. Bye-bye.
Thank you. Bye-bye.
Bye.